Okay, so we're going to look at lecture 8 of Specialist Maths Units 3 and 4, and we're going to look at algorithms and pseudocode. There's not really much prior knowledge for this other than sort of thinking logically and sequentially, so that's can be a bonus sometimes. Some of the key concepts we're going to cover are the definition of an algorithm. We've got if-then blocks, for loops, while loops, functions, lists, and finally we're going to look at what's called nested loops. As always, if you're finding the videos useful, please consider subscribing or liking so that we can spread the word a little bit. And as always, let me know if you've got any questions or if you are looking for any private tutoring. Let's have a look at this. So, an algorithm, let's think about what it is. An algorithm is a well-defined sequence of steps or instructions designed to perform a specific task or solve a problem. And then pseudocode is sort of the language that we write an algorithm in. Pseudo meaning we're sort of incorporating some English language into our code. So generally speaking, code helps us communicate with the computer, tells the computer what algorithm to execute. And then pseudocode is sort of like a mash between English and a coding language. In any case, we need to know a few things about pseudocode. And one of the things is that we can assign values to variables. So we use this notation and we would say that B is 3 in this situation. And then we can start to talk about the first things that we can do with our pseudocode. The first thing we can say is what's called an if-then block. So if some condition is true, then follow the instructions that you tell it, and then you end your if-then block. So here's a very simple example of an if-then block. If A is less than 5, set Y equal to A squared. Otherwise, let Y equal 10 minus A. So here we've got a slider for A. What I'm going to do is I'm just going to put it back to 0 for now. If we play that, we can see that as long as A is less than 5, we're going to get our A value squared. So we end up getting something that looks like quadratic. And as soon as it's greater than 5, we get 10 minus A, which is a linear line. So we get something like that. So that would be a pretty straightforward example of an if-then block. Um, and yeah, that's sort of just a visual way to show what's going on there. So that would be, yeah, our first sort of idea in pseudocode there. The next thing we're going to look at is a for loop. So this is sort of the general structure of a for loop. So we say for I from 1 to n, follow some instructions, and then we'll end the for loop. Okay, so again, a very simple example. Obviously, it doesn't have to be the letter I, sort of just conventional. So down here, we've got an example for k from 1 to 3. Plot the point k, comma k squared. And then we end the for loop. So again, if we change k, but now we're going in discrete chunks. Okay, so we're going to go 1, 2, 3, 4. So from 1 to 3 in this case, rather. So that's going to plot those points. So this point here is 1, 1 squared, which is the coordinate 1, 1, 2, 2 squared, which gives us the coordinate 2, 4, 3, 3 squared, which is 3, 9. So that's a very simple example of a for loop. Okay, let's have a look at the next thing, which is what's called a while loop. So similar to a for loop in terms of the way it's formatted, we say while some condition is true, follow some set of instructions, and then finally end the while loop. So let's just look at an example here. Consider the sequence y sub n plus 1 equals 2 times y sub n plus 5. And we're going to start with y sub 1 being 4. And our problem is to write an algorithm using pseudocode that will determine the smallest value of n such that y sub n is greater than 500. Okay, and then this might be an example of some code that we could use some pseudocode. So what we're going to say is to begin with, we're going to say n is 1, and we know that y initially is 4. So y starts as 4. And then we're going to use our while loop. We're going to say while y is less than 500, we're going to set n to be n plus 1. So that means we're going to go from 1 and then to 2 and then to 3. So we're just going to add 1 to our n values. And similarly, we're going to calculate our new y value, which would be 2 times the previous y value plus 5, because that's what this says, right? That's this rule here. Take 2 times the previous y value and add 5 to get your new y value. End the while loop and then print n. And then So you're probably wondering, how does that work or what does that look like? Well, what we can do is what's called a desk check to see what this code would output, right? Or what happens at each step. And I think this is important because it sort of helps you get into the code and think about what's going on. So hopefully we realize that n is beginning as 1 and we know that y is 4 to begin with. Okay, then as long as y is less than 500, well, y is less than 500 because it's 4, we're going to set n to be equal to n plus 1. So n becomes 2. And then we recalculate y. So it's going to be 2 times 4 plus 5, which is 13. Okay. 13 is still less than 500. So we are going to reiterate and go back through the code again. So n will now become 2 plus 1, which is 3. And then we take 13 and sub it into the rule again. We get 31. Keep doing that. N goes to 4. Sub in 31 into this rule. We get 67, still less than 500. Keep going. And eventually you'll get to n being 7 and y will be 571. So we can say that at n equals 7, y sub 7 equals 571, which is actually greater than 500, which is what we needed to do, right? We needed to find when y sub n was greater than 500, therefore n is 7, because we can say that y sub 7 is 571. So that code just runs through and finds, as we said, the smallest value of n such that y sub n is greater than 500. Okay, so the answer there is 7. So that's a while loop. Okay, it's going to get a little bit more tricky, but not too bad. I'm going to look at functions. So if you've studied the methods course or if just in general, maths is all about functions. A function, remember, has a very specific definition. Given some input, you get some output, and then you can have a one-to-one function or you can have a many-to-one function. A linear line would be a good example of a one-to-one function because every input has a unique output. Quadratic is a good example of a many-to-one function because multiple inputs have one output, which is okay. You're allowed to have that as a function. Okay, so this is how the sort of code might look for a function. You say define some function, and then you're going to put some input in. So you put something into it, follow some instructions, and then return some output. So for example, a function that we could do is the function of just adding numbers. So if you wanted to add two numbers together, you just add the numbers a and b. And that is a function because if you put two inputs, you're only going to get one unique output. For example, like when you add 2 and 3, you get 5, and that's unique. There's no other two numbers you could add together that would give you 5. So that means the addition is a function in mathematics. You can explore that idea a little bit more if you like. In any case, define a function which is going to add two numbers a and b. When we're just going to call the sum the addition of those two things. So we're going to add a plus b, and then we're going to return the sum. So for example, if a was 17 and b was 4, add the numbers. A is 17, B is 4, sum them together. 17 plus 4 is 21, and it will return the sum, so the sum is 21. So that's what that code would execute. Right, so hopefully a pretty straightforward example there. Okay, let's have a look at a list. So a list is a finite sequence and uses square brackets. So for example, we say that A, this could be our list for A, goes 0, 1, 1, 2, 3, 5, 8, 13, which hopefully you're recognizing is the Fibonacci sequence. And we can use this notation. We say A of n means the nth entry in a list. So in our example here, A of 6 would be 5. So 1, 2, 3, 4, 5, 6. The sixth entry is a 5. So A of 6 is 5. Okay, when we're sort of using pseudocode to do lists, we can use this command that's called append. So that allows us to add an entry to the end of a list. Okay, so what we can actually do here is we can see we've got some pseudocode, and what we're going to do is just dissect it. So we're going to define it as Fibonacci, and we're going to put some input n. Okay, and what our list will do is it's going to generate the Fibonacci sequence up to that number n. So for example, if n was 6, then we would get everything up to the number 5. and I'll show you that in a moment. But let's just run through the code. So we've got this A being assigned as this list. Okay, if n is greater than or equal to 1, append 0 to A. Okay, so let's just think about that for a second. If n is greater than or equal to 1, so down here we've got a slider for n. If n is greater than or equal to 1, we're going to put a 0 in the list. So that's pretty nifty, I think. If n is greater than or equal to 2, append a 1 to A. Okay, so if it's greater than or equal to 2, it's also greater than or equal to 1. So we're also going to add a 1 to the list. So we're going to get 0, 1. Okay, and then for I, from 3 to n, we're going to append the previous term. The previous two terms is essentially what this says. Add to the list the previous two terms added together. So when n is greater than or equal to 3, or from 3 to n rather, or yeah, greater than or equal to 3, or from 3 upwards, we're going to add the previous two terms together. So we're going to get 0 and 1. 0 plus 1 gives us 1. Okay, similarly, when it's 4, we're going to add the previous two terms together. 1 plus 1 gives us 2. And so on. 2 plus 1 gives us 3. And as we said before, A of 6 is 5. So that's what this code would sort of execute. A would be this list when n is 6. And so on. You can sort of keep going with that. So that is our, that's how we generate a list using pseudocode. And then obviously we end it and then we return A. So depending on what n is, whatever we put in here, we get this list. Now, if it's bugging you that these aren't square brackets, it's definitely bugging me because it was hard enough to generate this Fibonacci sequence. But I couldn't change from curly brackets. So you have to pretend that these are square brackets for a list. Okay, so that's how we do, yeah, that's how we create a list, or that's how we use pseudocode to get a list going. All right, almost there. Let's look now at nested loops. So a nested loop can be very helpful for solving a bunch of things, but it's essentially loops within loops. And the inner loop runs completely for each iteration of the outer loop. So let's just look at an example. It'll help. So create pseudocode that will find positive integer solutions to 3x plus 5y plus 3z equals 30. Okay, let's just think about this. We need positive integer solutions. So we know that if we take 30 divided by 7, that's approximately 4.3. So we can't really have numbers larger than 4 because then the x, this term would be taking up the whole thing. So we're sort of going to bound the sort of solutions we're looking for because, yeah, similarly, like if y was 6, well, that's going to take up the whole thing. And x and z would obviously be 0. So we're looking for solutions where x is between 0 and 4, y is between 0 and 6, and z is between 0 and 10. And hopefully you can see the logic of why we're only going to check up to those values because they're not going to be able to exceed that and still have the other ones having integer solutions. So our pseudocode might look something like this. So for x from 1 to 4, and then for y from 1 to 6, and then for z from 1 to 10. So what we're doing is we're nesting our for loops. And then we're going to say if 7x plus 5y plus 3z equals 30, print those solutions. Then end the if condition, then end the z loop, end the y loop, and then end the x loop. Let's just think about, sort of get into the code and think about what's going on. Remember, the inner loop runs completely for each iteration of the outer loop. So x from 1 to 4. So what that means is x is going to start as 1, and then it's going to move down, and then it's going to try y being 1, and then it will try z being 1. And if that's a solution, it will print that solution. If not, it's going to go back to the start. X is going to stay as 1, but now y, well, let's say y will be 1 again, and z now will be 2. And if that's a solution, it'll print it. If not, it will come back. X is 1, y is 1, z is 3. Again, x is 1, y is 1, z is 4. And you can see here, these are the only 3 solutions. And so none of those ones that I just mentioned would be solutions, but I think you would agree if x is 1, y is 1, and z is 6, that would be a solution. 7 plus 5 is 12, plus 3 times 6 is 18. 12 plus 18 is 30, so you can see that that's a solution. Okay, so that code will be executed and should print these three solutions. Now, just because we're curious maths people, we can think about this in sort of 3D graphics. Remember, this would just represent a plane in 3D space if you've done a bit of 3D plane geometry before. So if we come over here, we can see here that I've just defined 3x plus 5y plus 3z equals 30. So this is, again, the plane that satisfies, that has coordinates that satisfy x, y, and z, 7 times x plus 5 times y plus 3 times z equaling 30. So this is the plane that has all the solutions. So there's obviously infinitely many solutions to that problem, but there was only 3 integer solutions, right? And what you can see is here, it's a bit hard to see, but A, B, and C are all on that line. So again, these were our 3 solutions: 1, 1, 6, 2, 2, 2, 1, 4, 1. You can see that they all sit nicely on that plane. Okay, so that's sort of just bringing it all back to sort of real world, sort of geometry world to help explain what's going on there. But obviously that code only found, yeah, the integer solutions. Okay, hopefully you found that useful. Let me know how you're getting on, and I shall talk to you soon. Good luck.